Okay, in this tutorial I'm going to run through the basics of metallic bonding. So that's our third type of bonding and the last one that you need to know of in year 10. So cool, guys, the properties of metallic substances. Metallic substances, basically you'll probably know some of these from previous years when we looked at the properties of metals. So metals conduct heat electricity, they have high melting and boiling points, and most metals are solid at room temperature. They're strong, they're malleable, they can be hammered or pressed out into a shape, which also means they're kind of stretchy. They can be, you can press their shapes without breaking them. Ductile means they can be drawn out into wires, and they have a metallic luster. Basically, they're shiny. So why do metals have some of these properties? Well, it's got to do with what holds a metal together. So if we've got a lump of a metal, the metal atoms are actually held together. They're bonded together. Otherwise, it certainly wouldn't be a solid at room temperature. So let's look at what metallic bonding means. So, guys, metallic bonding occurs because metals often have extra electrons that they normally would want to get rid of. So if you look at the electrons, they tend to be on the left-hand side of the periodic table. They often have spare electrons in their outer shell. And so what happens is that they can kind of essentially let go slightly of those valence, those outer shell electrons, and they become what we call delocalized. So in my picture up here, you can see essentially the electrons are kind of flying around all over the show. So the positive bits here are the nuclei, are the nucleus of each metal atom. It's the core, and that's obviously positively charged because of the protons that are in there. But the electrons kind of become shared between all of them, so they're just flying around in between. So essentially a metallic substance, you can think of it more like a whole bunch of nuclei with electrons kind of in between them, acting like the glue that hold all those nuclei, the protons in those nuclei together. So yeah, that's basically what a metal's like. The electrons, at least the outer shell of electrons, become delocalized and are basically shared between all those atoms. And that means there's a whole lot of free electrons that can move around easily. So firstly, the reason they have high melting and boiling points is basically there's still a strong force of attraction holding these together. They're all attracted to those electrons, that cloud of electrons. So the center of each atom, the nuclei, are attracted to that cloud of electrons, and that still helps to stick everything together. If we look at its ability to conduct electricity, that's due to, remember, electricity is the flow of charge. If we throw in some electrons on this end, basically they can flow across or through and come out the other end. And that's because each atom isn't holding on to any particular electrons. They're all kind of shared and can move between one atom and the next. So this is what allows that flow of electricity, those delocalized or those free electrons in the metal's outer shells. It also explains why they're bendy, why they're malleable and ductile, because if we deform the metal, what we mean by that is we push it into a different shape. Unlike an ionic substance, there's no regular pattern here. So if we deform it, if we push it slightly out of shape, the electrons can just move to fill in the gaps and carry on sticking or holding all the positive, the nuclei or the core of the atoms together. Now, one thing I should just clarify there is remember, it's just the valence electrons. The other ones are probably still most likely remain with that atom. So it's just the valence electrons, I'd say, that are become delocalized. But again, it just means that these atoms, if we deform them, there's still electrons that can move freely in between, and they help to, again, essentially stick all the positive centers together, so that kind of like the glue holding that together. So that explains basically those key points, why it's malleable, ductile, sort of bendy. It explains why they have high melting boiling points and why they can conduct electricity. So we don't have that fixed pattern, that fixed arrangement we saw in some of the other types of bonding, but rather we've got this kind of sea or cloud of electrons that can move freely between atoms, that acts to basically hold the positive centers of those atoms in place or hold them together. Cool, so metallic substances is pretty easy. In terms of the properties, just think back to previous years when we covered the properties of metals. And that's basically it.